good afternoon, grade 8. So we are now in our week 4 lessons, which is about the axiomatic system or the axiomatic structure. So before that, let us introduce first the undefined terms in geometry. So we call them undefined terms because in geometry, these words that don't require a formal definition. So we can formally introduce these undefined terms by simply the representation of figures or pictures. Okay, so first undefined term is we have here a point is represented by a dot. Points are named by using capital letters. The points are named point A. So we have here point A, point B, and point C, or A, B, C. Points describe exact location in space. So in naming a point, we are using a capital letters. Okay, next word, we have here our next term. We have here a line is represented by a set of indefinitely many points with double-ended arrows. Lines are named using any 2 points or using a single lowercase letter. The line above or the line below is what we call the line L. Line L can also be line PR or line PQ. And then we have here the line QR. So a line has 2 arrows in opposite directions indicating that it has no end, therefore a line has no length. So these arrowheads nag-indicate that our line is extended infinitely, so it has no end. And then in naming a line, we can use here the 2 points in naming a line. So we have point PR. So we can use this in naming a line, also PQ and QR. We can also use a small letter in or the single lowercase letter in naming a line. So we have here line L instead of line PR or line PQ. So pwede man kita ka-use lowercase. Take note class that a single line is composed of many points. So, hindi lang na di 3 points ang makitaan ta sa isa ka line. So, possible na may-ari pag ginadi siya, damo nga points. Okay, next we have here a plane is represented by a flat surface. Though a flat surface is viewed as something with length, width, and a little thickness, a plane has no dimensions. A plane is named using 3 of its points that do not belong on the same line or capital letter that do not represent any point. So the plane is named using any of the following. So we have plane P here in the figure, plane ABC, and then plane ADC, plane BDC. So plane ABD cannot be used as name of the plane because points are contained in one line. So take note, mag-name ka mo gani isang plane. So pwede ka mo ka-use single letter P. Dapat ang P na siya, wala na siya nag-represent sa mga points inside the plane or on the plane. And then, mag-use naman kita sa mga points. Dapat ang aton points wala naga-contain sa isa lang ka line. So, dapat ang isa ka point or at least 1 point wala sa the same line. Wala sila naga-lie on the same line. So, for example, point C. So, si point C does not lie on this line. So, pwede tayo ma-name as plane ABC. So, hindi pwede si plane ABD since ang tatlo ka points are sa isa ka line. So, we cannot use it in naming a plane. Next, we have your example. So, use the given figure in determining the following. All the points. So, let's identify all the points. So, we have point P, Q, R, S, T. So, we have here the points and then let's identify the 4 different names of the line. Okay, so we have here line RS. So we have line RT, line ST, or line M. Next, in naming a plane. So for naming a plane, one letter name for the plane. So of course, ang wala nag-represent some point, that is plane L. Next, a three-letter name for the plane. So we have here plane PQR. PQR. And then, what else? So, pwede man si plane RSP. Pwede man si plane RSQ, plane STP, plane STQ, and many more. So, the undefined terms are point, line, and plane are used to define or represent some concepts in geometry. So, these are the undefined terms in geometry. Okay, so we have here the definitions. Collinear points are points that lie on the same line. So, kindly look at in this figure. So, we have here 3 points that lying on the same line. So, we call them a collinear points because these points lie on the same line. So, nagalay si point P, point Q, point R sa line L. So, ang tatlo ni ka-points, makitanta sa isa lang ka-line. So, we call this a collinear points. Next, we have coplanar points are points that lie on the same plane. So, we have here plane P. So, si point A and point B, ara sa sulod sang plane or on the same plane. So, we call them collinear points. Si point A and point B. Next, intersection of the set of points that is common to both figures. Intersection could be a point, a line, or a plane. So we have here two lines intersect each other. So kung naga-intersect ganing aton nga two lines, two or more lines, so may ara sila point of intersection. So we have here a point sa ilang agin tabuay. If we have two planes intersecting to each other, so kung duwa naman ka planes na nag-intersect, and then the point or the intersection is a line. So kung ang duwa ka plane nag-intersect, ang ilang intersection or ang ilang gintabuay maka-form into a line. Okay, so in the study of geometry, statements are classified into three, namely definitions, postulates, and theorems. So in definition has been used in the previous lesson, so that is giving a meaning to a certain word. So minsan definition, naghatag kita sang meaning. A postulate is a property or rule that is accepted without proof. So, kung ihambal ko lang na siya, no need to be proven because that is already accepted as true. A theorem needs to be proven first before it is accepted as a true statement. In proving theorems, postulates may be needed. Okay, so sa theorem, need na gini siya i-prove. So the following statements express relationships among points, lines, and planes. They are accepted as true. We have postulate 1, a line is formed by at least two different points. So we have here 2 points, and then we have here a line. So a plane is formed by at least 3 non-collinear points. So we have here 3 points. So if you notice, ang tatlo ni ka points wala nagalay on the same line. So therefore, we can form a plane using these 3 points, non-collinear points. So space is formed by at least 4 non-coplanar points. So therefore, ang apat ka points dapat wala nagalay on the same plane. So at least may point siya sa gwa. So this is what we call, we can create here or form a space. postulate number 2, through any two different points, there exactly one line. So take note again ha, postulate, we don't need to prove it because it is already, the statement is already true. So any two different points, there are exactly one line. So sa isa ka line, so given 2 points, we can have now a line or one line. Through any 3 non-collinear points, there are exactly one plane. Postulate number 3, if 2 points lie on a plane, so ang duwa ni kuno ka points are sa plane, then the line containing these 2 points are also in the plane. Take note ha, nga 2 points determine a line. So, duwa ka points, maka-form ka na line. So, sa postulate number 2, 4, if 2 different planes intersect, then their intersection is a line. So, man siyang aton nga plane, if they intersect to each other, the intersection is a line. Next, we have postulate number 5. There is one-to-one correspondence between the points on the number line and the set of real numbers. So there is a unique distance between any two different points on the number line. The distance is obtained by getting the absolute value of the difference between the coordinates of the 2 points, or that's what we call the ruler postulate. Okay, so we have here, for example, a number line. So sa atong number line, may ara kita naga-correspond. So we have point A. So si point A may naga-corresponds kung ano siya nga number sa atong number line. So that is 3. So si B naman niya, gina-corresponds niya nga number sa number line is 10. So hindi always nga 3 ang gina-corresponds ni A ha. So this is for example only. Siya amo na sa ang ginanya means ng one-to-one correspondence. Okay, next we have betweenness for points. If 3 points P, M, Q are collinear, meaning these 3 points lie on the same line, kay collinear siya mo. And PM, so we have here the segment PM plus the segment MQ is equal to segment PQ. So if you add these two segments, so si segment PM, i-add mo siya kay segment MQ, and then, ang segment niya total, that is segment PMQ. Then, M is between P and Q. Next, we have here the congruent segments. If two segments have equal lengths, then they are congruent. So we have here an example of congruent segments. So we call this ang line siya, we call this ticks. So 2 ticks on each segment indicating that they are congruent. So kung pila ang number of ticks, or if these segments or sides sa isa ka triangle, may parehas sila number of ticks, meaning they are congruent to each other. We have midpoint of a segment. If a point divides a segment into 2 congruent segments, then the point is called the midpoint of the segment. So we have here segment AB. And then, so point M divide the segments into 2 congruent parts. So from AM going to BM, equal lang ang ila-length ni AM kag ni BM. We have the bisector of a segment. If a line, segment, ray, or plane intersects a segment at its midpoint, then it is called a bisector of the segment. Okay, so we have here a line or a ray which passes through or intersects to the midpoint of our segment. So aton segment is a segment AB, and then ang aton midpoint is si point F, and then may nag-agi nga isa ka a line or segment, which is segment CD. So, kung nag-agi siya sa midpoint, then we call segment CD as the bisector of a segment. So, may siya aton nga bisector. Segment CD. Next, if two different lines intersect, then the intersection is exactly 1 point. So that is our theorem 3.1. So if two lines nag-intersect, then their point of intersection is a point. Exactly 1 point. Theorem 3.2, if two different lines intersect, then they are contained exactly one plane. Theorem 3.3, if M is the midpoint of segment AB, then 2MA is equal to AB, or MA is just 1/2 of AB. Okay, so let me discuss this again. So we have here our segment AB. Si M, ang aton nga midpoint. So, di ba ang midpoint, it divides our segment into two congruent parts. So, therefore, si segment AM kag si segment BM equal. So, kung duwa ka MA, duwa ka segment MA, okay. So, if we have two segment AM or 2AM, so on 2 times na lang sang length ni AM, that is equal to the length sang AB. Or pwede man niya si MA or si AM is just 1/2 sang aton nga segment AB. So, kung ang measure ni segment AB is 10, so kung ang measure sang aton nga segment AB is 10, therefore, ang measure ni AM is 5, and then ang measure ni BM is 5. Since equal ni sila nga duwa, si AM kag si BM, kay si point M, dinadivide yung aton segments into two congruent parts. Okay, let's have another example. Okay, so what if the length of segment AB is 20 units? Okay, so pilang measurement ni AM? So si AM, that is 10 units, and si BM is also 10 units. So ang ginahambal diot 2MB, so 2, pilang measures ang aton MB, which is 10 units, is equal kuno sa measures ang aton nga AB. So pila aton measures ang AB? Of course, that is 20 units. So equal, so 2 times 10, that is 20. So 20 is equal to 20. Next, betweenness for rays. If three rays, ray AJ, okay, so we have here ray AG, ray AF, ray AE. So maghambal kita gani ray, bali isa lang siya ka arrowhead. Ari lang ang may arrowhead, then the rest sa last end niya is a point. So arcoplanar and angle angle FAJ plus the measure of angle FAE is equal to the measure of angle GAE. So the same man lang to gyapon sa aton nga previous to nga gin-discuss sa midpoint. So diriya sa betweenness for rays. So we have here a ray. which divides our angle. Okay, so if you add these two angles, measure of angle FAJ, and you add the measure of angle FAE, so the measure is equal to angle GAE. Okay, so this angle plus this angle, so ang total nila is ang ari nga angle. Okay, so that is the betweenness for rays, where the ray FA or AF is between ray EJ and ray AE. We have the angle bisector or the bisector of an angle. If a ray divides an angle into two congruent angles, then the ray is called the bisector of an angle. So, dili naman yang gina-divide ta is the angle or the angle bisector. So, we have angle AOB, and then, ang naga-divide sa aton angle is si segment OC, or pwede man siya ang ray ang maka-divide, ray OC. Okay, so we have here the angle bisector theorem. If ray OC is a bisector of angle AOB, then twice the measure of angle COA is equal to the measure of AOB. Okay, so again, if the measure of our angle AOB is 60 degrees, okay, so for example, ang measure sa aton nga angle AOB is 60 degrees. Okay. So, si OC, gina-divide siyang OC or ray OC divides our angle into two congruent parts or congruent measures. So, pila na di ka degrees ang aton nga AOC. So, that is 30 degrees. And then, ang aton naman nga angle COB is 30 degrees. So, twice the measure kuno sa aton nga angle COA is equal to the measure sa aton nga angle AOB, which is correct. And then, the measure of angle COA is just half the measure of angle AOB. So, same also man sa angle COB kag AOB.